Okay, so let's start. It is time. So I am Sapanjana. I am a PhD student in mathematics department in IIT Bombay, and I am also a PMRF scholar. I am also an integral part of nptel course noc23-ma27. That is the name of the course is integral and vector calculus. So today is the week 9 discussion session. Today we shall discuss about volume integrals and its application. So we shall start from basic motivation, and then we shall see some problems, and in the latter half an hour we shall see polar form, and we shall see some applications for volume integral. So let's start. Okay, just wait a minute. Okay, so let's share my screen, and then okay. I hope my screen is visible to all of you. So if it is not, then please confirm. Otherwise, I shall start now. Okay, so let's start. Okay, so today's date. So we shall first start with basic motivation for the volume integral. So we have seen line integral, double integral. So now we shall see integration. So one by one we shall go. First one is the integration of over a bounded function over a parallelepiped. That is, a parallelepiped is given by r equals to R equals to AP cross CD cross EF, right? And then, as usual way, we take, so let us take, okay, let me write in white color. Let us take partition T1 to be x0a xn equals to b, E2 to be a partition of CD. Let us denote it by C less than Y1. Now this index may vary, so it may not be same. That is, NM may be distinct. And P3 is Z0 equals to E less than Z1, Z2 dot 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 ZP summon A. And we denote, so if we these are arbitrary partitions, arbitrary, right? Now these three partitions give rise to these three partitions give rise to a partition, say P equals to content of WRST such that 1 less than equals to R less than equals to N, 1 less than or equals to S less than equals to M, 1 less than equals to T less than equals to P, where WRSTUP defined the product, the interval XR minus XR times YS minus YS ZT minus 1 comma ZT, right? And that is true for every R, S and T. And as usual, we denote MRST to be a per bound of the given function over WRST, and MRST to be lower bound of the given function over the same WRST, and we denote UPF equals to summation R equals to 1 to N, S equals to 1 to M, T equals to 1 to P, M R S T times W R S T, right? And LPF is defined to be the quantity, the same with the minimum R equals to 1 to N. And I hope you are now getting idea why I am doing all these things, because in case of Riemann integral, then you here it is just single variable, only one summation. For double integration there are two summation. Now for triple integration it is three summation, and in general so here it is to in general there will this quantity will contain in many summations. So let me just write here in general the above sum contains n many summand for integration of in Rm, right? Okay, so now the if you look at the picture, so let me show the picture. So this is your my was the given graph. This is given, and as usual we want to approximate this curve by upper and lower. So here in one picture I have seen, so here this partition, this one corresponds to a partition which has less number of points, corresponds to less number of points in T. This the second one, this one is first one, and this one is second, third. So second one contains more points, and third one contains more. And if we keep on taking more and more and points, that is taking supremum over all possible partitions, then we obtain the resulted one, that is this on the fourth. This on the fourth. So I am writing all these things, so let me write. So now the number of points in one is the one is nothing but corresponds to less number ones. So number one corresponds to a partition which contains less number of points than 2 than 3 in the picture. And fourth one nothing but at infimum of all possible partition UPA equals to supremum of all possible partitions LPA, right? So in that case, in such case, we say if, okay, so let me first write the notations. We denote R over U, so FDP to be the upper integral sum, upper integral and this one said to be the lower integral sum, right? And now we say f is integrable if, as usual, both the quantities are same. And in such cases, we denote RFDV to be the all this quantity. Right? So this is the case when we consider the given region is a parallelepiped. So this was the case when given region is a parallelepiped. So now we shall see how to compute for volume integral for a region when the region is bounded by surfaces. Okay, so the same idea. So here calculation of triple integral or volume integral, or you can say, or volume integral of a continuous function on a bounded domain bounded by surfaces. So here let me write say z equals to, okay, so z equals to phi of x comma y comma psi of psi x comma y. It is a function of both x and y, and y is a function of x, gx comma h of x, right? y equals to y equals to and pi should it. Okay. And x lies between in between. Okay, so and x between x equals to a, x equals to b, right? So this is the surface that is given to me. Yeah, right. And you can also say that the functions phi and psi that satisfies this is less than or equals to psi of x y, and g x less than or equals to hx, and obviously a less than b. So now in such cases we denote in such cases the volume integral becomes e f of x y z dx dy dz dx dy dz equals to x equals to a to b, y equals to gx to hx, and z equals to phi xy to psi xy, f of xyz dx dy dz. So here I let us write, to not make you confused, so let's write dv, because you have to properly maintain order. But if you want to write, then you can write also equivalently. That is nothing but actually x equals to a to b, y equals to gx to hx, z equals to phi xy to psi xy, that is if xyz, first integration is with respect to dz, then dy and dx, right? So if you have any doubts, then please ask. I shall move to the now problem solving. So if you have any theoretical concept not clear, then please ask me. And everything will be clear if you look at the picture, because here the given region is the last one, fourth one, and 1 2 3 are nothing but approximation of the graph by upper sum and lower sum, as usual Riemann integration. Only thing that here the variable number of variable is 3. Yeah, so everything is exactly same as Riemann integration. Only thing that is happening here is the number of variable is 3. So let me write exactly same as Riemann integration, but only thing happening extra is that number of variable is 3, and idea is exactly same as Riemann integration, right? Okay, so now let's go to problem. So we shall now solve some problems, at least 10 problems we shall solve. So as usual, the first step will be always to visualize, at least to draw, because still we are in 3D. So we can draw at least the picture, or we can imagine in our mind where we need to find the volume integral. So the first problem is given that find the value I, where I is the triple integration of the function x plus y plus z plus 1. This sometimes this is known as also integrand, and its square dv. So I have written here dv because I don't know what is the ordering of integration so far. After I get the ranges of x, y, z, I can write what is the ordering of dv, and what is the region given. Given is the 2 into mod x plus 3 into mod y plus mod z less than or equals to 6. So if you look at the picture, then okay, so let me simplify the equation first. So that is 2 into mod x plus 3 into mod y plus mod z equals to 6, right? Now if you divide by 6, then you will get mod x by 3 plus mod y by 2 plus mod z by 6 equals to 1. So where mod x, when there are 8 possibilities cases. What are the possibilities cases? X, y, and z. X can be both negative positive, y can be both negative positive. Similarly for z also, it can be both negative and positive. Okay, so when this is plus minus plus minus plus minus, and what are the all possible? Okay, so this is the possible cases. Okay, so and what will be the all possible cases? Plus minus plus 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 all. Second one will be plus plus minus. Third one is plus minus plus. Fourth one is minus plus plus. Fifth one is, and now start with 2 minus 6 minus plus minus. 7 one is plus minus minus, and 8 one is minus minus, where this one for x, this one for z. So you will get 8 equations from here, and 8 equations will nothing but will lie in 8 different coordinates. Thus we get 8 different equations, and all of them lies in the all different quadrant in R3. As in the picture, if you see, this is nothing for the picture it is drawn here. This is for the part in the first quadrant, in the quadrant where x, y, z all greater than equals to 0. So now in this case the equation nothing but x by 3, because y positive, y by 2 plus z by 6 equals to 1. So it will be, the point here will be So let me here. Okay, that will be not 3, this will be 6. So let me put in black color. This is 6 and say this is z axis and this is x and this is y. This is origin. Then what is x? X will be cutted at 3 and this will be cutted at 3. Similarly, if you draw lines in the other directions, so let me, yeah, so similarly for z axis also in this direction and negative in y axis also. So you can draw all in 8 different coordinates listed here. So however, note that it is enough to find in one quadrant and to multiply it by 8 because all the coordinates are symmetric. So let me write this. Since since all the parts in 8 different quadrants are symmetric, it is enough to find the value as in picture, that is x greater equals to 0, y greater equals to 0, z greater equals to 0 and multiply it by 8, right? So the required volume integral will become thus the required volume integral is 8 times x equals to 0 to 3, y equals to 0 to 2, sorry, y equals to 0 to 6 minus 2x by 3 and z equals to 0 to 6 minus 2y 2x minus 3y because when x equals to, so you have to draw here lines parallel to x axis, y axis and z axis, right? So when you draw lines parallel to x axis, then it goes 0 to 2, 0 to 3, and then if you line draw parallel to y axis, then you will get from here to this equation, this line. But this equation is obtained by putting z equals to 0, that is the equation becomes then 2x plus 3y equals to 6, right? And from here y equals to 6 minus 2x by 3. You can write the same for y also. You can take y equals to 0 to 2 and x equals to 6 minus 3y by 2. And the plane is given by z equals to 0 to this. And what is the integrand given? That is actually x plus y plus z 1 whole square dv. But now I know what the integration is going to, or what is the order of the integration. So we can write now the order of dv in terms of z equals to 0 to 6 minus 2x 3y x plus y plus z plus 1. So first integration is with respect to z, then y, and then dx. If you want to make convenient, then you can put the bracket here also. And this one turns out to be x equals to 0 to 3. It is nothing but basic calculations, but still I am showing you. Okay, y equals to 0 to 6 minus 2x by 3, and okay, so for the simplicity case, so let it make only the linear term, because I don't want to go for the calculation, because it's nothing but calculation, and you can easily, if you set up the volume integral, then you can easily go do further squares, but it will only do nothing but the heavy calculation. So to avoid that, I have just make it linear term, and so this everything will now be linear. Okay, and this one, okay, right. So now then it will be x times 6x 6 minus 2x minus 3y plus y times 6 minus 2x minus 3y plus 6 minus 2x minus 3y the whole square by 2 plus, and 6 minus 2x minus 3y, and whole this integration is first with respect to y and then second with respect to x. So now if you simplify this, then it will turns out to be x equals to 0 to 3, y equals to 0 to 6 minus 2x, and c x minus 2x square minus 3xy plus 6y minus 2xy minus 18x square plus 36 42x square 9y square 24x 18y 12xy plus 6 dy dx, right? And then if you further simplify, so I will not complete it, but I will simplify it as much as possible for you. So it will turns out to be 6 minus 2x times 2x square minus 20x plus 42 plus 6 minus 2x whole square by 2, 7x minus 15 minus 9 times 6 minus 2x whole cube by 3, right? And that is now only single variable and integration, so I will now left it as for you. it is nothing but a single variable integration, right? Okay. So if you have any doubts in understanding why there is eight quadrants and why eight possible equations is coming and why we are multiplying it by eight, then please ask. Otherwise, I shall move to the second question. Okay. So no problem. Okay. So let's move to the second question. Okay, so what is the question? The question says find the volume V of the solid bounded by the bounded by the right circular cylinder x square plus y square is equals to right. So now the cylinder x square plus y square equals to 1 and the xy plane and the plane x plus z equals to 1. So the first step will be to draw the picture. I have already posted it over here, so you can just have a look. And so yeah, so the first step is step 1 is step 1 draw the picture. Okay, if I draw the picture, so step 1 is already following from as I have already drawn them. Now second one is to step 2 is to convert the to set up the volume integral, right? So for that, so first you note down that the what is the this one. So here it is the and here it is your xy plane, and this side here this one is xz plane, and this side is yz plane, right? Now the circle is nothing but x square plus y square is 1, that is given. Okay, so now the equation of the circle is given x square plus y square is 1, and what is the equation of x plus z? So the equation of x plus z will lie in the xz plane. The equation x plus z will lie in the xz plane, right? And since x is also varying, because x is varying over the unit circle here, so x is also varying over the unit circle in the xy plane. Right now, see, when your point is here, so suppose your x is here, then the x plus z will belongs to here. When your x is here, then your z will coincide with the point itself here, and when your x is here, then your z will lie here. When x is in the opposite direction, that is upper half plane, then your z will lie down. So in I mean the xz plane will be this surface, the upper one, this one will be your x plus z equals to 1 surface. So now so you see in this picture what is the ranges of x, y and z is varying. So if you this one is unit circle, so the point one is 1, I mean 1 0 0 0. So and this one is minus 1 0 0 0. Okay, sorry, if you I have written y axis, so let me change it. It should be 0 1 0, and this one should be 0 minus 1 0. So this one is 0 1 0 and this one is 0 minus 1 0, right? So x will lie between minus 1 to 1 and y will lie between in between this circle from here to here. Y will lie between here, right? And z will be from along this plane, xz plane. So in this picture, from the picture what we have got, so let me write. From the picture we get x lies between minus 1 and 1, y belongs to root over 1 minus x square to x square, because what is the x, so this side is the way you will think. So I am thinking this one to be positive, so this side is root over 1 plus 1 minus x square, and this side opposite here it is root over 1 minus x square, and this side is root over 1 minus x square. Sorry, this will be 1 minus x square, right? And what is the z lies between? So since already given in the question, so if you look at the question, that the solid bounded by xy plane and this one and the radius of xy plane mean it is above the xy plane, so z will be always positive. And how far it will go? It will go up to x minus 1, because z lies in the plane z equals to x plus y, z plus, that is z equals to 1 minus x. And because the solid lies above the solid lies above the, because the solid lies above the xy plane, right? So now the volume integration will turns out to be, so thus the volume is given by integration 1 dv, but now you can write x runs from minus 1 to 1, y run, as I have already told that you never forget to write down the in which variable you are writing the limits, otherwise it will mix up you. And z equals to 0 to 1 minus x, here there is no integrand, so it is constant function 1 and dv. But dv here I know what is the order of the integration. The first integration is with respect to z, and the second one is with respect to y, and then last one is with respect to x. So now let's calculate this quantity minus 1 to 1, x equals to this, y equals to minus of root over 1 minus x square to 1 minus x square, and there is constant function, so integrate it will be z. So and ultimately by putting the limits it will turns out to be dy and then dx. Then again we need to integrate x equals to minus 1 to 1. So first one will be y minus xy. So 1 minus x integration 2 root over 1 minus x square dx. Fine, because it will be y, and the both negative negative will be positive. There will be two quantities. So now this is actually equals to 4 times integration, because 1 minus x square is an even function, so I can write at minus 1 to 0 and 0 to 1, and since it is even function, it turns out to be this quantity root over 1 minus x square dx, and this one is integration 0 to 1 root over 1 minus x square dx plus integration 0 to 1, sorry, there will be some negative sign here, and this one is minus, sorry, this one is minus x root over 1 minus x square dx, and this is on. Now you know the formula. What is root over of a square minus x square? That is nothing but x by 2 root over 1 minus x square plus a square by 2 sine inverse x by a. Here a is 1, and what is the integration then? 0 to 1 minus 4 times. So if you take x square to be change of variable z, then 2x dx will be dz. In particular, I mean this will be 2 times 2 times in so integration 0 to 1 root x dx, right? Yeah. So now this quantity will be 0, because if you put x equals to 1, okay, so there it will be 4 times, here 1 and 0 both will cancel out, but here 1 half and sine inverse 1 is pi by 2 plus 2 2 by 3 and x to the power 3, x power to the 3 by 2, that is 1. So that quantity will turns out to be pi plus 4 by 3. I think I have some done some mistake, if I not wrong. Yeah, here you cannot change. Here the variable that I have changed, this quantity is not an even function. This is an odd function, so you should tell me at least. So this step is not correct. This quantity is an odd function, so you can't do 0 to 1 by multiplying it by 2. So it will be root over 1 minus x square dx minus plus minus 1 to 1 minus 2x root over 1 minus x square dx. So this is an odd function, and the range is the symmetric, so this quantity will turns out to be 0, and the formula that you know, root over 1 minus x square plus half sine inverse x minus 1 to 1 plus, and this will be 1 minus x square whole power 3 by 2, 2 by 3 minus 1 to 1. And this quantity is again, now if you put 1 and minus 1, this first term will be vanished, and the second one, it will be pi by 2 minus minus plus again pi by 2, right? And here also both the terms will cancel out, and finally the answer comes out to be pi. So if you have any doubts, please ask. Otherwise, so yeah, so otherwise I have to go to the next problem. If you do not have any doubts, then it is fine. If you have doubts, then please ask. I shall go to the next problem now. Problem number 3. Okay, so let's start problem 3. So problem, what does the problem says? It says that find the volume of the wave cut from the elliptical cylinder by the planes z equals to 0 and z equals to y plus 3. Okay, so here nothing, picture should feel like you can draw easily the ranges of x and y and z. So given elliptic equation is 9x square plus 4y square equals to 36, that is x square by 4 plus y square by 9 equals to 1. So how does the ellipse looks like now? It looks like, okay, so now if you put this to be its origin and this one is x-axis, then x hits the here minus 2 to 2, x lies between, and y lies between minus 3 to 3, right? So now the so if you now draw the 3D equation, then how will it be? So let me then, yeah, so now I have to write all these things accordingly, because yeah, so now let us make it as z-axis, and remaining to be this one x, y, and this one z. Let me draw the ellipse again. Right, so this ellipse lies in the xy plane where z equals to 0. So now, and the given plane is z equals to 0, that is this plane is x equals to y, and y z equals to, so this is yz plane here, this is your this is your yz plane, and this is your xz plane, and this one is xy plane. So now if you given elliptic equation this, and so what will now the plane will look like? So it will look like the last picture I had on the y plus 3. So this will be 3 and this is minus 3 and this is 2. Here somewhere it will be minus 2. Right? And then, okay, so let me put a dotted line here. Okay. So now it will be somewhere y plus z. So it will hit y at minus 3 and z at 3. And say this one is 3 and this one is minus 3. So it will look like, so for better picture you should look at uh, I think problem number 2. So let me write for much better picture, just have a look at problem 2. Right? So now you can easily draw or find the ranges of this integration. So thus the volume integral turns out to be, so x belongs to, okay, let me put in terms of y because I have written down the calculation for these ranges. X belongs to minus of 2 by 3 root over 9 minus y square to root over 9 minus y square. Z belongs to 0 to y by 3. Or you can also check, you can also take, you can also take x belongs to minus 2 to 2, y belongs to, what is the y? That is minus root over 36 minus 9x square by 4 to root over 36 minus 9x square by 4, and z belongs to anyone. It is up to you which one you want to choose. So 1 or 2. This is 1 or 2. Right? So now I shall solve the 1. So solve 1. Right? Let's start. So integration now become y equals to minus 3 to 3, x equals to minus 2 by root 3, 9 minus y square to 2 by 3 root over 9 minus y square, z equals to 0 to y plus 3 z dx dy, and this one is equals to y equals to minus 3 to 3, x equals to minus 2 by 3, 9 minus y square, t by y tz tx. Sorry, this will be tx and then dy dy, and then it turns out to be 2 into y equals to minus 3 to 3 y plus 3 into root over 9 minus y square. So it will turns out to be integration with respect to x to, yes, 2 by 3. There will be some scalar 2 by 3, and this is dy. However, this turns out to be 4 by 3 minus 3 to 3 y root over minus 9y square dy plus 4 by 3 minus 3 to 3 root over 9 minus y square dy. Now again proceeding in the same way, then you will get 4 by 3 minus half times 2 by 3 times 9 minus y square whole power 3 to minus 3 to 3 plus 4 half into 9 pi, that turns out to be 8 pi. Yeah, so this is nothing but a simple calculation. So if you have any doubts, then please ask. Otherwise, I shall move to the second problem. And as usual, so I will stop recording here, and then and again I shall start recording, because my laptop cannot proceed the 2 hours session at a time. So let's stop recording and then